All right, there you go. Cricket Ramon's House of Math. Thank you for reminding me for recording. Okay. What do we have? We had, and we even missed it because Muda Mukau has already made an appearance. He gave him the data. But anyway, what did Mui tell you? He told you after 3 hours, there were 9 cakes in the factory because we're going back to the cake factory where there's no machinery and just the guys. And after 5 hours, there was 13 cakes in the factory. How fast are they making cakes? All right, David. What's the most amount of 3s we can count out of 9?
3.
Oh, okay. What's the most amount of 5s we can count out of 13?
You can only count 2.
You can only count 2. You're right. Okay, well, that method isn't going to work this time. Remember, sometimes we could figure out if it was the same amount, we would know. Okay, well, on this one, it's 3, and on this one, it's 2. So that's not how it's going to work. So, let's see here. Let's find. Well, let's see if we can find some other kind of pattern. What was the trick for figuring it out every time?
The
What was it? Can you remember?
The formula
What was the formula?
that you find the difference between the
There you go.
dy
dx. dy dx.
yeah, the y and the x.
dy dx. dy dx. dy dx.
That's a cow, right? That's a cow, right? Not a python.
That's a cow. Yes, it is not a python. He's a cow. A python? Why would you? How dare? Why would you think I was a python? That's crazy.
Because if you live in Florida, the Everglades,
Well, we're in Arizona, and there's no alligators in Arizona. All right, you. What's dy dx? Tell me.
ydx.
Yeah, what's the difference in y's and what's the difference in x? So here's what I want you to do. Okay. The difference in x is definitely 2. I'll take that. What's the difference in y?
The difference in y is 4. What?
David, where do those numbers come from? 4 and 2. And what's the difference between what does this mean? What is 4 over 2 then? What's the rate going to be?
Wait.
What's 4 divided by 2?
4. 2.
2. All right. So here is my equation over here. I'm going to say y equals, what's y? Y is the total number. This is x. This is y. David, you never did explain to me where the numbers came from. So explain to your little sister. Where do the numbers come from? Well, here's where the numbers come from. Wait. You. What's the difference between 5 and 3? Oh, 2. What's the difference between 13 and 9? Oh, 4. So what are we calling this? This is the difference, dy. Oops.
And dx.
And this is the difference in x, dy dx. And what we do is we divide this by that, and 4 divided by 2 is 2. So now we know our rate, right? Okay, now if my rate is 2, that means 2 times 3, oops, but 2 times 3 is only 6, and it's 9. So what do I have to add? Oh, wait, and 2 times 5 is 10, but it's not 10, it's 13. So what do I have to add in both cases?
You have to add the... Wait a minute. So,
David, wait, don't say another word, Vivian. David, this is supposed to be 9, but when I multiply by 2, I only get 6. So it's supposed to be 9. How much do I have to add to get to 9?
You have to add 3 more.
All right. And over here, it's 5, and 5 times 2 is 10, but it's not 10, it's 13. So how much more do I have to add to 10 to get
3.
to 13? There you go. So it's going to be y equals 2x plus 3. So what does that 2 tell you? What does the 2 tell you?
Tells you that so I know they started with 3.
They started with 3. So at 0, if I put x is 0, then y is 3. You are absolutely correct. What if x was 1? Then what? What's y going to be?
And it'll be 1 times 2 plus 3,
Which is?
which is 5.
And then there's 3 times 2 plus 3. There's 5 times 3. So how many would they make after 8 hours, which was the original question?
They would make.
Wait, don't say anything. David, how many would they make?
They would make 19.
Why? How do you know?
Because 8 times 2 plus 3.
That's very good. That's very good. That's good. Because math. That's how you know. Because of math. All right.
Because of math.
Because of math. What's 2 times 8? 16. Plus 3 is 19. Got the right answer. All right. Let's graph this. So let's see here. At 0, when x is 0, y is 1, 2, 3. When x is 1, y is 5. When x is 3, oops, 3 is missing. 1, 2, 3. Then it should be 9 way up here. Boonk. Okay, and then if I went all the way out to 8 over here, it'd be all the way up here at 19. 19. All right, so wait, I can even do it. Do it like that. Boonk. And I'll get an idea that it should be like right about there. All right, look, I can draw a line. What's this line? Y equals 2x plus 3. That's that line. This point right here is 0, 3. This point right here, let's say, is 3, 9. That would be this one, 3, 9. And then over here, if I had 5, and I would draw it, I know that 5, and this would be 13. Right, 1, 2, 3, 4, 5. Should be maybe closer like that. Okay, 5, 13. Okay, make your graph. Now, I didn't get a satisfactory answer from you, Vivian. What does the 2 mean? What does the 2 tell us?
That's times 2.
What's times 2?
The number of hours times
Yes,
2.
is times 2. Why is it times 2? What does times 2 mean? David, how many cakes are they making each hour?
Each hour?
Yes.
It started with 3.
They started with 3, but how many are they making each hour?
5.
2. That's what a 2 means, you goofy. That's how many cakes they're making. That's the rate. All right. What we have here is y equals mx plus b. B is the constant, what we started with. What's m? Well, m is the slope of this line. Slope. Look at the slope. Right there, slope. Right? And what is the slope? It says you go over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2. Why? Because the slope is rise over run. Rise. Now here, I'm going to give you this one thing, Vivian. Well, also you, Dave. Rise, run. Rise can be uppy downy. Run is always positive. So this is plus or minus. This is always positive. That one thing will save you much grief. Now, so m is the slope. It's the rise over run. What else did you tell me? It was the rate. It was how fast we were making cakes. What else is it? I'll give you that for homework. Come back and you tell me. You could even look it up and cheat on Google or whatever. But slope, rise over run, rate. So this told me, this 2, Vivian, told me how fast we were making cakes, which is the whole point of doing dy dx. And that's another thing we could put over here. is m is the same thing as dy dx. We'll see later on when you're doing calculus, you'll do dx dy. But for right now, we're doing dy dx. We'll be doing integrals and derivatives, but all right. You ready for another one?
Yeah.
Okay. Dun dun dun. David, you ready for this one? I'm gonna try and leave my. Oh no, I can't. There's no way I can't do it. I'm gonna try and make it so that. Oh wait, before we go on, let me see your graphs. Hold them up to your. Oh, and by the way, let's see. Oh, I like it. I like it. Okay, and that line is continuous, by the way. So when we draw the line like this, you put an arrow there and an arrow there.
Okay.
It goes wherever in each direction. Because we could go negative and we could see what was down there. Right? Technically.
Oh, he used the 100 block.
Yes. There you go. Perfect. That's what I do. I take the 100 block, I put a piece of paper on it, and then I just rub it, and then you get an instant graph paper. So if you don't have graph paper, you can always use your 100 block. You like see how it works?
Yeah, I drew it on the paper, but it's very, very big.
Oh, wait. Hold on a second. Okay, I'm trying to find a piece of scrap paper or something that I can, or any paper that I can do it on. Oh, look, a piece of legal paper. Okay, so, but then I need a pencil, which I don't have. Because I'm down here and I'm not surrounded by pens. No pencil.
Hey, next minute, you're pulling a pencil out of the camera.
Okay, there you go. Let's see. Do I have one?
Okay, that would be real.
That would be cool. Okay, nope. More pens, more pens. I'm surrounded by pens. Oh, wait, here's a whole bunch of pencils. There's a whole box of pencils. All right, here we go. Well, then my pookie poop put all the pencils back and none of them sharp. Okay. Oh well.
Can you move?
All right, so look, here you take your block, right? And then you just go like this.
Oh, yeah, true that.
Can you see? And then it makes you can make the lines. Anyway, if you do it carefully, you can make a nice little sheet of graph paper. See?
Wow.
Okay. Let us try. We'll send Mui off to another donut factory. Put this like this, this like this. Yeah. We can keep going this way and keep going this way. All right, so now, Mui, get over here and give us the information. Okay, so once again, if Mui would just get there on time, we would know if there was any cakes in the factory to begin with, right?
Yeah.
We had a cake factory. Okay, so it goes over to the cake factory. And he says, after, what does he say? He says, after 3 hours, there's 15 cakes in the factory.
Wow.
After 5 hours, there's 23 cakes in the factory. Okay, did you write it down?
Okay.
So at 0, we don't know again because he didn't get there in time.
Okay.
After 3 hours, what do you say?
I just read the graph.
It was 15. After 5 hours, It was 23. So how many did they start with? How many after 8 hours? And then I'm going to ask you if they have 47 cakes in the factory, how long have they been working? Look how much information you can give me. Now, here's the thing, Vivian, you want to see something kind of cool?
Yeah.
I can just put these 2 points on a graph. You have graph paper?
Yeah.
All right. So then just go 3 and then go up to 15.
Oh, I've always had trouble doing graph questions in school.
Okay. Well, that's going to end today.
Okay.
All right. So I got to make 15 because I'm only at 10. So hold on a second here. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, look, I'm already at 23 over here. So we're off the graph. And then over here, I only got to go to 5. So I'm good. So let's see here. We're going to start at, we go over 1, 2, 3. What does that say? 3. Vivian, you're not looking. Vivian, that's 3.
Yeah.
Okay, so that tells me what X is over 3. Then what does that tell me?
Oh, why?
Which is way up here at 15. You need 2 pieces of information to figure out where I am. Because if I just say 3, 3 doesn't tell me anything. But if I say 3 and then I say 15, I know I'm right here. Well, actually, wait. I got to count. And I can measure. That's 10, 11, 12, 13, 14, 15. It's right there. So at 3, 15. And if you count the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There it is. And over here, 1, 2, 3. Okay. And then what? I should go 5 and 23. So 1, 2, 3, 4, 5. There's a dot missing again. And we go all the way up here to 23, which should be way up here. Okay, now here's the thing. Just drawing the line between this one and this one will tell me the whole thing because I only need 2 points to graph a line, right? And then I can take my straight edge and I could draw it. All right, but we can also calculate this line. And see, every point on this is everything right here is a point on that line. But we haven't figured out the line yet. What's the dy dx?
Dy dx is dy dx equals dy dx.
Can you look at this? I can look at it in my mind and I can see the difference between these two is 8 and the difference between these two is 2 and 8 divided by 2 is what?
8 divided by 2 is 4.
There you go. So what's my rate? How fast are they making cakes?
They're making cakes 50 times an hour. Wait, so
how many times an hour did we just figure out, little boy?
4.
4. So the number of cakes, which is y, is 4 times the number of hours.
That's 3.
Plus 3 again. Because you're right, because 4 times 3 is 12, but it's 15, so I got to add 3. 4 times 5 is 20, but it's 23, so I got to add 3. So there's my thing. And so at 0, we started with 3. How many after 8?
How many after 8? So it will be 35.
Good answer, because it's right. 4 times 8 is 32, plus 3 is 35. All right, can we draw a line now? So I know I start at 1, 2, 3, right? 0, 3. And then the next point would be what? 1 and 7. So there's 3, 4, 5, 6, 7. At 1 right there. Bunk. Right. 7. Is that 7? 1, 2, 3, 4. We'll go 5, 6, 7. We'll put it right there. All right. And then 2 would be what? Well, at 2, I should be where? Really, guys? What's 4 times 2? Is that hard?
8.
Plus 3.
12.
One more time.
Hmm?
8 plus 3 is never going to be 12.
11.
All right, so right there. And then look, it is on the line. All right, so see, and then I can draw a line. If I had a straight edge or a steady hand, boom, that's a pretty steep line. In fact, it's terrible because I didn't make it straight. There you go. All right, and that line is y equals 4x plus 3. Now, here's the thing. Where is it going to cross the y-axis? It's going to cross over here someplace, right? But we can calculate that. We can know exactly where that's going to be. You could either draw the line on your graph, or we could figure out, well, what's x equal? David.
Yeah.
Let's play what's advanced under the cup. What do we want to do? We want to put x by itself. So right now, if I want y, I know I got to take, in order to get y, I got to take the hours, multiply by 4, and add 3. What do I do to get x? Well, that's over here. I know that x is supposed to be, excuse me, y is supposed to be 47. I have to figure out what x is. So, David, 47 is the same thing as 4x plus 3. What do I have to do? What's the first thing we do in What's Under the Cup? Maya, what's the first thing we do when we play What's Under the Cup? What's the first thing we have to do?
Measure.
That's what I said. What's the first thing we have to do when we play What's Under the Cup? Vivian, what do we do?
We measure, right?
Well, okay, oh, I see. She said measure. I thought she said Maya. Okay, and yes, we're going to measure on the state. And what do we do? What are we doing when we measure? What we're doing is figuring out what's same on both sides. Yeah. So I'm going to take away 3 from over here. I'm going to take away 3 from over here, right?
Yeah.
Because I know there's 3 here and 3 there. Because 47, can I say that that's 44 plus 3? And 44 plus, take away the 3, and I get, now it's 40. What's 7 minus 3?
4.
All right, so now that's pretty easy. 4 times what is 44? But that's not how we do it. What we do is, in order to find x, I have to, right? That's no fun, because I don't want to know about 4x. I want to know about 1x. So what's no fun? Get back to 1.
No fun, get back to 1.
So I got to divide by 4 both sides. And so now I know x is, this is 1. X is the same thing as 44 divided by 4. What's 44 divided by 4?
44?
Divided by 4.
4. It is 11.
It is 11. Good job.
Because 4 times 11 is 44.
There you go. All right. So now let's take a look at this and we can figure out what x is. Watch this. Watch this. I'm going to do algebra. What do we do? Step 1, we subtracted from the total number 3 because that was this over here. And how do we get that? Well, over here is 0, 0, right? 3 and negative 3. So anyway, here's 4x. That's been explained numerous times in numerous videos. Okay, and then what? Then I got to take y minus 3 and I got to divide it by 4. And that will give me x. Oops, I should do it in 2 stages. Boom. Right? I got to do this. Boom. All right. And then it tells me that x is the same thing as y minus 3 divided by 4. Right?
Yes.
So I know when x is 0, y is 4. What happens when y is 0? What's x?
X, when y is 0, x must be. I just go get something.
Okay, go and come back. I just told you y is 0. So let's put it in here. What I tell you, y was the same as? Y is what? Y is what?
Y is 0.
Y is 0. Okay, I'll write it like this. Y in blue is 0. So I'm going to tell you that the y over here is 0. Okay,
And then
now you tell me what it is.
Negative something.
Negative something. Well, you tell me. It says, what's 0 minus 3?
0 minus 3 is negative. Huh?
Yes. What? How hard is that? What is 0 minus 3?
Negative 3.
There you go. Why are you trying to make it hard? I see you over there trying to make it hard. Negative 3. Then what? Over 4. There you go.
Yes.
So that means that when y is 0, x is negative 3/4. So it's not even 1. It's 3/4 of 1. Right? That's what this point is right there. That point right there, you can label it and you can say that when y is 0, x is negative 3/4. There, I just labeled that point right there. That's called the x-intercept. This is the y-intercept. Okay. And the way you know how we find the y-intercept is we figure out when x is 0, what's y? So then we got to figure out when y is 0, what's x? Right? And that'll give me this point and that point on the, right? So a lot of times what can happen is you get like this point and then the point over here, and you get those two things. And like I said, once you got 2 points, you can draw the line. And once I draw the line, then I can, right? And then I don't have to plot every single point. And same thing over here. If I know 2 points, I can draw the line.
Oh, yeah.
I like to see your graph, young lady. And where did David go?
He's here.
Well, he's just off camera. I see. Okay, I see your knee over there.
Now you see me?
Yes, now I see you.
Wait, can I make sure on the steep line that is x equals 4x plus 3, the last dot is on 15, right? Not 14, right?
Yes.
Oh, okay. I think I made a mistake then.
Well, why? Because 3 is 15, right? When x is 3, y is 15. When x is 5, y is 23.
Oh, okay. Oops.
If I go all the way over here to 11, I have to go all the way up there to 47, and I'm never going to get it. I mean, I'd have to start my graph way down there in order to plot that point, because it's way up there. It's at 47.
Yeah.
It's already 15. This is like 23, wasn't it? Or 21?
I see it now.
Okay. Excellent. All right, now we're gonna get crazy.
Why?
Because we're gonna do fractions.
Ooh!
All right, so we're not even gonna make whole cakes anymore. We're gonna make portions of cakes.
Okay.
But I'm gonna start the other way around. I am gonna. Oh, let's see. Hold it still. Make some noise so I can. The people at home can.
It's there.
Of course, you guys are always silent when you need to be making noise. All right. Anyway, hold it. Oh, yeah, hold it up. Hold it up. Maya, what song do you know? Okay, put it down a little more. Every time I talk, the camera comes back to me. That's why. Okay, now, like I said, now you got to make some noise. Okay, I got to give you a kazoo or something so you can play the kazoo. All right, that's very good, by the way. That's a good graph. I like it. That's a good job. Okay, now let's get crazy. Like I said, and what shall we do? We shall
go crazy.
We shall get nuts. And here's what I'm going to do. You want a hard one or an easy one to start? Let's start with an easy one. Let's start with easy. Why? Oh, we're not going to use that pen, are we? How about this pen? Why? Oh, I like it.
Why?
I have girlfriend hair right here. This is my girlfriend's hair. This is not my hair. My girlfriend has hair like you, long black hair, because she Asian, just like you, and it's everywhere, including stuck to my pens. And she doesn't even come over here, and still yet. Okay, anyway, y equals 1/2 x. I don't know, plus something simple like 1. Can you draw a graph of that?
1.
Well, what does that say? Let's figure it out. Let's figure out some points. So what happens at 0? Well, at 0, it's 1. At 1, it's 1.5, isn't it? A half of 1 is a half, and plus 1. At 2,
So they started with 1. And
yes, started with 1, and then after 2, I would have 2. Right?
So it goes up by half.
There
half.
you go, because that's the slope. Exactly. That's my rate. It goes up by a half, goes up by a half, goes up by a half. Exactly. All right. So now I can put in a number that's even. Like, what if I put in, because see, every time I put in an odd number, I'm going to get a half, right? But every time I put in an even number, I'm going to get a whole. So if I put in, like, say, 6, half of 6 is 3 plus 1 is 4. So I can say 6, 4.
Now I have to draw a graph, right?
And then I could put in 10. Yes, you draw the graph. 10, right?
Wow.
If x was 10, what would y be?
If x was 10, y would be...
David.
Oh, yeah?
Either one of you. But David, what's half of 10?
Half of 10, 5.
All right, plus 1. What's half of 10 plus 1?
Half of 10 plus 5 plus 1 is 6. It'll be
There
6.
you go. There you go.
Oh, easy.
Oh. You know that this is fractional because the x is bigger than the y, even though, right?
With the blocks. I draw the house with the blocks.
Let's see.
Bring it closer.
Oh, that's very good. You could, and now you know what you could do? You could actually put your blocks on top of your drawing, Maya.
You put the blocks on top of the drawing we made. Oh, yeah.
Yeah. You can make it like, say, that's where you put your blocks for your drawing. I like it.
So, Maya, this is how much?
And here, Maya, do me a favor. Before you do anything else, have Maya build 10s on top of that 100 block.
Ooh, okay. Anyway, David, can you get her 10 blocks? 10 blocks.
Yeah, she's going to need a 1 and a 9, an 8 and a 2, etc. And she's going to need her 100 block.
Here, Mimi. This is 100. Mimi, can you read it? 100.
There you go. No biting the blocks.
I'll read it to you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17. You missed out 13.
You missed 1. At the end, you got to be at 20. Are you going to count to 100 on the block? That's going to be amazing.
14, 15, 16, 17, 18, 19, 20. Very good.
That's 2 10s. And she can keep going.
2,
All right, hey, wait, Maya. Before you do that, put the 1 and the 9 and the 2 and the 8 and the 3 and the 7 and make it look really colorful. David, give her the block she needs to make it.
David, give it her.
She builds it and David gives her the blocks. Okay, yeah, you can start with a 10.
Okay, Maya, put the 10 there.
So put the 10 on.
Oh, put on your block.
Yeah, put it on there. And then grab 1 and 9, Maya.
1 and a 9. Good. You're using both hands.
Yep.
And you take
Let's see what you did so far. Oh, nothing so far. Okay, let her try to use 2 hands.
Yeah,
Okay. There you go. Now there you go. Perfect. Put it the other side, Maya.
Oh, other side.
Put it with the 1. There you go. And then put the 8 over there. Very good.
Oh.
So what did I do? I just dropped the cognitive load for the older ones to 0.
Can I draw the graph?
Yes, that's your whole point right now. Yes, do that. Draw the graph.
I don't know if it will be correct.
It will be fine, and I know it will be correct because you're the one that's going to do it. So let's see here. And see, on this one, I can do the whole graph will fit right here on this. So let's do it. Wait. I'm trying to get that. Okay, there.
Y equals half. No, my other way. Go there.
Okay. So I'm looking at this and I see at 0, it's 1 right there. And then what? At 1, it's 1.5 right there.
Oh,
At
yeah.
2, it's 2.
Oh.
Boom, right there. Perfect. Should be a square, actually. So wait a minute. Oh, because you know why? It's because messed up over here. This will be 1, 1. That'll be 2. There you go. And there you go. So that'll be 0, 1. And then see, 2, 2 should be right there. And then there should be a 1 in between it. Boom. And I should be able to draw my line like that. And what is that? That's y equals 1.5 x plus 1. Now, here's the thing. I know over here at 10, this should be 1, 2, 3, 4, 5, 6 at 10. And sure enough, it's about right. Wait, 1, 2, 3, 4, 5, 6. See, my line is not. There you go. This other line was too steep. So anyway, when I get to 10, it should be 2, 3, 4, 5, 6. Should be right there.
Is it because 6 and 4?
And then it should be 6 and 4. Let's look at 6 and 4. 1, 2, 3, 4, 5, 6. And then I should be able to go up 1, 2, 3, 4. And I kind of got it. See, if I had actual graph paper, I'd be hitting it exactly, right? Because each one of these points is on this line, is supposed to be on this line.
And then
Let's see.
oh,
You did a very good job. It's very nice and colorful. It's very pretty. Good job, Maya.
That's all your combinations for 10.
wow. Now what do I do next?
What do you want to do? You know what you should do? Tell your brother make a game of what's under the cup for you. That's what you should do. Tell your brother get some cups. At least one cup.
Oh, see? It's correct.
All right, let's see your graph.
Let me see 10 first.
Okay.
1, 2, 3, 4, 5, 6. Wait, maybe I need a. How many cups do we need?
For Maya, probably just 1 or 2.
Okay.
Start off with 1. You guys got to go store and get some of these.
Okay. Hey, Mom, we need to go to the store to get
Just buy. You can buy one at like $2, and you get a whole bunch of red cups.
Wait. Is it plastic?
We can use that.
100% plastic. I don't know. This is a very common item in United States because everybody's an alcoholic. That's even better. I like it. Coconuts. Do it. Use the coconut one.
Okay, can you
No, because blocks won't fit in the white cup, Maya. It's too small.
Okay.
All right, we gotta hide. All right, David, make your equal sign. You need 2 3s to make your equal sign.
Yes.
And Vivian, I would like to see your graph, Miss.
In mine.
Have you got an equal sign? Oh, you have one in mind? Do it for her then.
My line is not lining.
All right, let's see.
English is not Englishing because I see here on the graph if it's 6 and 4 is 1, 2.
Well, first off, how come you're not using graph paper?
It is.
Well, then just use the graph paper. Just use the natural thing that's there. Don't make your own. Don't be like me. You don't need it. So just use the natural graph paper that's there. Now, here's the thing, Vivian. If we could change scale, Vivian.
Yes.
And you can make every square 1, but you could also say that this is 1. So then you can make it bigger. So every 2 is actually 1. And then this would be a half and a half, right?
Oh, yeah.
You know what I'm saying? So sometimes you might want to make your graph. If the graph paper and then what inside, let's use a lighter blue. Inside, this would actually be 4 boxes, right? But we're going to say that instead of it being 4 boxes, it's actually just 1. And we cut our 1 into quarters. You understand?
Yes.
Okay. So basically what I'm doing is taking my 1 and doing that. If I blew it up, made it big, look. You're not looking. Right?
Yeah.
This would be 1 all the way to here, and that would be my half. So this would be 1, right?
Oh!
Make sense?
Yes, now it makes sense.
Okay. So now can you draw me a nice graph, please?
Okay.
David, I thought you were making a problem for your sister. You're playing on the keyboard.
It's not a normal piano. It's like this. You blow in the tube.
Yeah, it's got a what do you call yeah, Vodafone or something like that. All right. Did you make a problem for her?
David made it.
Okay, what's the problem? Let's see.
Yeah. Put the 8 there. And count.
Can you tilt the camera down just a little bit? Because I can't see. Vivian.
Yeah.
Can you tilt the camera down just a little bit? Because I cannot see what she's doing. There you go. Although I'm in the way now. All right, David. Remember when I had the other problem where it was 47 was the same thing as 4x plus 3?
Yeah, but there are 2.
All right, what does it have to be? What's it have to be?
And you chop it into. Oh, so you have 1, 2, 3, 4. So half of 8 is 4. Then if you split this up, imagine you break it, you get these. Is this enough to put in each one? Each one? Yes. Okay, then check. Is it correct? Yes, and then that one.
Yay! I like it in your coconut. Each one had a 4, right, David?
Now I'll make a harder one.
Okay, so the problem that you gave her was 2x, right? Plus I don't know what was the same thing as what? 2 cups plus what was the same thing as what, David?
It was 8 on 8 was on that side and 16 was on that side.
Okay, there you go. Very good. So 2x plus 8 was the same thing as 16. And she figured out that each x had to be 4. Because this would be the same as 8. So 2 of them, like what you explained to her, you have to break it up. And there'd be a 4 and a 4. Very good. All right, let's go back to Vivian.
Yeah.
So now if I let me draw this. Y equals 1/2 x plus 1. So when x is 0, y is 1. So I'm going to change my whole scale here, get rid of this, and I'm going to draw this thing out. Oh man, it's going to be terrible. But I can do it. Watch, watch, watch. Ooh. Ooh, yes. Okay. And then what? Then I got to do that and that and that, and that, and that. And I got to keep going here. You see what I'm doing? I'm making my boxes, right?
Base done. Come. Wait, I need to go.
All right. And then I got to get rid of all this stuff in here. All right. So each one of these now is going to be 1. So that means that at 0, I have 1 right there. Oh, and then what? At 1, I have 1.5. So that would be like right here. And then what? At 2, I have 2. That would be right there. At 3, what would I have?
You would have
What's a half of 3?
half of 3 is 1.5.
1.5. What's 1.5 plus 1? 2.5. Right? Because each time it's going up over 1, up a half, over 1, up a half, over 1, up a half, right?
Oh yeah.
Excuse me. Is that right?
Yes.
This tells me 1 over 2. This is the rise. This is the run. And I told you this can be positive or negative. Right now it's positive. So the rise is 1. But then I got to go over 2 and then up 1. Right? So this says up 1, right? Over 2. Or over 2, up 1. Over 2, up 1. So start here. And if I go over 2, I go up 1. And then if I went over 2 more, I would go up 1. But you see right here, I'm stuck on the half. You see how it is?
Yeah.
And then I can draw my line. Oh, it's terrible. I missed totally. Oh my God. Could I do it worse? I couldn't do it worse, so I tried. All right, there you go.
So what is 10? If you break into half. Yeah. So let's see. 1. No, I want to do it. 1.
All right, let's see your graph.
This one? Yeah. But you need to do 1.
Mine was bad.
It's not that diagonal.
Let's see. Oh no, it's good. But the thing is, you got to work on your scale, young lady.
Yeah.
All right, so here's the thing. If you have your graph like this, then this should be 1, this should be 1, it should be the same, right?
Well, yeah, mine was maybe not the same.
All right, so draw it again.
Okay.
Flip your piece of paper over.
Bang. Oh, no wonder. I think you need cheese. I see it.
All right. So start with your little origin like this, and then put some points and draw your line. And technically, you only need 2 points.
True. Even more.
And wait, what was my equation? Was y equals 1/2 of x plus 1. So here, just make 2 points. 0 and 1, this one. And then what? Let's put in 8, which would be 8 and 5. And then you just have to put 2 lines and you're done. Let's see. Yes, that looks good. That'll be your 1, right?
Yep. I'm not done yet, me.
Okay. And then you got to show your brother David when you're done.
So you can start above the 1?
And then where do you start? At 0, 1. That's where you start. Because when x is 0, y is going to be 1.
Oh yeah.
All right. And what? When you put in 2, what are you going to have? Well, at 2, it's going to be 2.
For example, if what do I mean? If the x, no, if y, if y actually starts at 3, then it will start at 3 and not 1, right?
If this is 3.
Yes, then it will start above.
Yes, because when x is 0, this would be 3, right? So like in the other one, if you were doing y equals 4x plus 3, well then on this line, when x is 0, it would start at 3. Right? But with this one, when x is 0, it starts at 1.
Oh, okay. I think I can make my graph now.
And then when x is 2, well, y is 2. When x is 4, then y is 3.
Okay.
So here's that. Here's this. Thunk.
So it's like a whole chocolate bar.
There you go. There's a slope of a half. That's a perfect slope of a half right there.
Yeah.
Right? And technically this is sine 30 right there, because that angle right there is 30 degrees. Anyway.
Oh, I see.
All right, and then what? Then I'm gonna go a little further, and then I'm gonna go a little further this way.
I forgot to put them on here.
I can't make the.
There. Okay, mate.
There you go.
It's a big one. It's a big one.
Better. All right, now I got that, and what's that? That's gonna be.
It's hardest. It's hard. I put this 7. Oh. Okay, I'll give you a twin. All of this is 24. It has.
There you go. Now I'm starting to.
No. So
correct. So what are these points, Vivian?
No. What is the middle of 24? Okay.
Let's get rid of all this so it doesn't look so crazy. All right.
So there are 4 numbers. Okay. There are 2 numbers you can have.
All right. So what? Now I can put my line. I know. Okay. Here is 0, 1.
6.
Here is 1 and 1/2, and I'm not going to draw it. Here is 2 right there, and 2.
6.
Right?
Yep.
And actually, with just those 2 points, I could draw the whole thing.
Oh, 18. I think I've done it correct this time.
There you go. So what? I go over 2 up 1, right? Because the run is 2 up 1. So over 2 up 1, over 2 up 1. Okay, so if I go down 1, I got to go over 2.
All of this is 30, right? So if
I know that line right there, that right there is when
okay.
y is -1. Excuse me. What is it? When x is -1.
I did it. Yeah, it fits. 24. It fits. So 24, right? It takes. It has 4.
So if I want y to be 0, what is x going to be when y is 0?
2 2s. So
in other words, when this is 0, what's x?
9. Then I'm going to show you.
Well, just put it in. 0 equals 1/2 x plus 1. Well, let's see here. What's that going to be?
You got it, but I think it was a bit too hard. Is this correct? I just get something.
Much better. Yes.
Yep.
Now you have to. There you go. I can see she's happy. Now you just got to get used to the graph paper 1 1 1 1, right?
Yeah.
So here, do me a favor. Draw me a picture of y equals x.
Y equals x.
Y equals x. What would that look like?
So that will look like y equals like.
So in other words, if I was going to have y equal to x, that would mean that when I had my ordered pairs, they would always be same, right?
Yeah.
So if y was 0, x would be 0. So if x was 0, y would be 0. If x was 1, y would be 1. If x was 2, y would be 2. What would that line look like?
Oh.
I think it would look something like that.
Oh yeah, it will be a straight line.
I'll just say, oh yeah, you got to draw it. Put it on your graph.
Okay. you put it on my phone.
What, right? Because what? What am I doing? All I'm doing, miss, is graph. What? This is 0, 0. This is 1, 1. This is 2, 2. This is right. This is 3, 3. This is right. And then if I wanted to move it up, I could add x plus 1. Then it would start here, and it would be a parallel line. And if I wanted to say x plus 5, then it would start way up here at 5, and then it would do the same thing. Right?
Yeah, because I know the flavor. Yeah. Okay, I'm gonna draw it up just the square. Thank you.
Okay.
Okay, let's start. This is 0, 0, 0. So 1, 2, 1. Oh, it'll look like.
Here's the thing, too, Vivian.
Yeah.
Tell your mom, or you can, with your phone, take a picture of your graph and send them to me.
Okay.
Okay.
Okay. Oh, I think Maya. Okay. Now let's make a new question. You didn't tell me. Do you want easy or hard?
Just give her a hard one, just for fun.
Okay.
But not too hard.
Yeah. I gave her a really hard one. Something like this.
Yes, not something like that. Exactly like that. Keep going the other way, too. Can you go back the other way below? Can you go this way?
Yeah. You can
It's
also
be the
go
same, right?
Yeah.
So what's that going to be? That means when y is -1, x is -1. When x is -2, y is -2, because they're the same.
The same.
Now, we have a couple of other concepts to cover, which is negative slope. Very good. Excellent. Okay, and I just put a few labels there. Label a couple of points and tell me x and y. There you go. What are you doing in there? Making salad?
Ones.
You're making a salad of ones?
I need a sprinkle of threes.
A sprinkle of threes. There you go.
Oh.
It's a lovely salad.
And some lemon sauce.
There you go.
Then a few pieces of orange.
You're making a fruit salad.
Yeah.
There you go.
One is the kiwi.
The pink can be the guavas, the yellow can be the lemons, and the orange ones can be the orange ones, and the green ones can be kiwi.
Oh, yeah.
That you chopped up.
It's so big.
There you go.
The 5. Oh yeah, 5. The light blueberries.
The light blueberries.
And there's a dark and light blueberry. But the dark blueberries are too big.
Okay. Oh my goodness, we went over time again. We always go over time. It's okay.
Okay. I'll put some more guava.
All right, you two.
And some
we never got to the sun list, and we never did all right. Anyway, it's okay. So you guys practice your sun list. Show David, try to find your sun list, and if you can't find your sun list, Vivian, do you have yours?
Yeah, I can.
And make him copy yours since he lost it.
Okay. I think I remember it. 1 is sun, 2 is socks, 3 is traffic light, 4 is
What is 4?
Car.
Car, yes, because 4 wheels, right?
Yeah. And then 5 is glove.
Yep.
Yeah, 5 is gloves.
And then wait, what letter is 5?
5 fingers.
I know, but what letter is it?
Oh,
A, B, C, D, E. Right?
Yeah.
A traffic light is C.
E.
Right?
Yeah.
Okay. And then car is D.
Yeah.
Okay, put all that in there in your sun list.
And 6 is soda. Yeah.
There you go. Why is 6 soda? Because 6 pack of soda, right? You get 6 of them usually. You get 6 cans.
10 is toast.
That's not exactly how you sell them in Singapore, though, I noticed.
Penny
But in the United States, they sell a 6-pack. They sell a 6-pack of cans. 3 and 3.
and 11. 7.
All right.
Seven.
So, young lady, I would like you to go out there in the internet land and find out a little bit more about graphing. Okay, now that you have a pretty good idea of how it works. But see, nobody ever tells you, oh, the ordered pairs, how to get ordered pairs and make a graph, how to make a graph and get ordered pairs, and how to graph and get ordered pairs out of this and how they relate. And then the difference dy, dx, and so forth. Okay, let us call it a day for today. You guys did really well. Oh, wait, before we quit, let's do some quick drill for skills.
Okay.
David.
Yeah.
What's 8 times 9?
8 times 9. 62.
7 times 9 is 63. What's 8 times 9?
72. 72.
72. Very good. What's 4 times 4?
4 times 4 is 16. 16.
What's 2 times 4?
2 times 4 is 8.
What's 2 times 8?
2 times 8. 16. 16.
What is 4 times 4?
16. 16.
Still 16. What is 7 times 3?
21. 21.
Very good. What's 4 times 7?
4 times what?
7.
4. 24.
4 times 7.
28. 21.
28. Because 6 times 4 is 24. All right. So if you know 4 times 7 is 28, what's 14 times 7?
14. 1 to 8.
Oh, try again. What's 14 times 7? Not even close, Vivian.
2 to 8.
Oh, my goodness. What's 10 sevens?
70. Oops. 70 plus 70
You have
plus
to see
21.
70.
Yes, now you realize you're being silly.
70 plus 21. No.
7 plus 28. That's 14. Would be how much?
8.
98.
You know what?
And you guys are all over like 128. Just guessing numbers. Not even close.
You know what 7
All right.
times 15 is?
What is 7 times what?
7 times 15 is 105. The 70 plus 35.
Yep, is 105. There you go. Okay. What is what's 19 times 9?
19 times 9 is just take 9. I know. 9 is 109.
Oh, you're so far off. That's actually painful.
Wait, no. 19. It's not
19 nines.
19 nines is. Oh, I got it. No. 171.
Oh man, I was getting tired of waiting. Yes, 171 is the correct answer. All right, David. Yeah, you should have got that. What is that? That's just 90 and 81. 171. What is 6 times? Oh, let's try a different track. Let's do 2 digits. What's 13 times 12?
13 times 12. 12 times 12, we already know is 144.
There you go. Very good. So what's 13 times 12 then? Right. 12 times 12 is 144, but that doesn't help.
Okay, I got it. No, 156.
There you go. And look, I'll make a quick picture for you so you can do that. Oh, look, here it is. Bunk, 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 bunk. 150, and 6 is going to fit right there. So what's 13 times 13?
13 times 13 is, I know, 169.
Very good. And I saw you look at it in your mind for just a second. You took a picture of it in your mind. All right. What's
196.
Very good. What's 16 times 17?
16 times 16, what does that equal?
16 times 17.
16 times 17. Then you just plus.
Yeah, then you just plus. What are you plussing? Well, I'm gonna plus when I say 16
116
times 17. So it's gonna be 200, and right there is going to be 230, and 6 times 7 is 42. 272.
Wait, is it? Can you also do 170 plus 42 or no?
No, because that's not everybody. Or is it? Because 170 plus 42 is not 272.
230.
There you go. 230. Why is it 230? Because what you have here, just add all these tens up. If I add 7 to 6, I get 23 tens, which is all of these guys, right? Watch. There's my 100.
Okay.
Then what? Then I'm supposed to be 16 over here. So this would be 6 tens. This would be 7 tens. So if I just add the 7 and the 6, I count up all of this right here, which is 230. And then I just got to figure out what's in the corner, which is 42.
Oh. Now
See, that's what I did right there. There's my, right? And there's that right there. Make sense?
Oh, yeah.
Guess what? Well, I'm just adding up. So, all right, let's do another one.
Okay.
I don't know. Pick two numbers. How about 14 and 18? Well, what? I already know that's going to be 22, right?
Yeah. Oh,
And what is that? 22. 22 tens is what I'm talking about. And 4 times 8 is, what's 4 times 8, David?
4 times 8 is 40.
Wait a minute. What's 4 times 8?
4 times 8. 220 plus 2.
4 times 8 is 32.
Wait.
So what do I have?
0 times 2 is 0. 2 times 6. 252.
252 is the right answer. Dave's over there doing all kind of crazy stuff. 14 times 18, 252. Look, I can draw a picture of it. I'll draw another picture of it. Here, oh, wait. In fact, let me get a better picture because you guys...
times.
All right. What am I drawing right now? Hey, what am I drawing?
I'm in a froggy position.
You're in a froggy position.
It's the
All right, what am I drawing? What's that right there? It's a big red square is what it is. Then what? Then it says I'm supposed to be 14. So it has to be 4 tens here and 8 tens there. So when I add all this together, I wind up with 220. And then what? The 32 is in the corner. That's all it is. When I add these two, all I'm doing is adding up all of this.
Huh, yeah.
And that's going to be 220. Because what is that? That's the tens. We're counting the tens.
You look upside down.
You look upside down. In fact, you look ridiculous. All right, you guys. Next week, what are we going to do? I think we're going to do some more of this. But like I said, go fool around on the internets and see what you can find out about graphing y equals mx plus b.
Okay.
And then, David, between now and the next time I see you, play What's Under the Cup with your sister. And aren't you guys supposed to be fooling around with fractions?
Yeah.
All right. So fool around with fractions some more, and we'll fool around with fractions some more next week.
Which sister?
Maya, of course, not you. All right. Crouton Ramones, houseofmath.com.
Bye.